Hi and welcome everyone. So in this video we will interface ultrasonic sensor with Arduino UNO board and we will measure the displacement. So ultrasonic sensor, that is HC SR04, this is ultrasonic sensor. So it is having four terminals, one is VCC 5 volt and another one is ground. This is the power supply terminals, and trigger pin and echo pin. Basically the trigger pin is actually an input pin for this sensor, and echo pin is an output pin, that is output signal that is coming out from the sensor. There will be a 4 MHz crystal oscillator is there. It is actually the transmitter, it is the receiver. Actually the working principle of this ultrasonic sensor is it is actually inspired from the bird bat. So actually bat is actually producing ultrasonic sounds, right? So ultrasounds, we know that ultrasounds, that is which is higher than 20 kilohertz, the sounds are called as ultrasounds. The very important property of ultrasound is it can able to reflected from even from the water surface. So reflective index is more for that sound signal, so it will be reflected even if you are showing in front of the water surface, it will get reflected. So it is a property of ultrasound. So the bats are actually using these ultrasounds to find out whether the obstacles are present in front of the bat or not. So it is producing ultrasounds, as you can see in the picture. Similarly this ultrasonic sensor is producing the ultrasounds and it is getting hit by the obstacle or object in front of the sensor, and it is getting reflected and it will be received at this receiver. So in order to generate this ultrasounds, there will be a crystal oscillator is there. So actually this is the working principle of the ultrasonic sensor. So we know that there is a formula for the speed formula. We know that speed is equal to distance over time. So time is equal to distance by time, distance is equal to speed into time. So we know that the sensor is actually producing the ultrasounds. The speed of the sound is nothing but 340 meter per second, or otherwise it is equivalent to 0.034 centimeter per microseconds. So this we know the speeds, right? So the time whenever it is getting released and it is getting back through the echo pin, right? So that is why the sensor is employed with two signals, two terminals, that is trigger pin and echo pin. Trigger is nothing but it is output pin. It is sending the ultrasounds through this pin. So since it is output pin, it is sending the ultrasounds from the sensor to that atmosphere, and then it will hit the object. If it is object, if the object is present in front of that sensor, it will hit the object and it will be reflected back to the sensor. It will be received, it will be measured with a pin called echo. So only we are telling echo is input pin, echo is input pin, and trigger is output pin. So it is mistakenly given here. So trigger is output pin and echo is an input pin. Then so we need to measure the time, actual traveling time of that particular ultrasounds. So it is started from sensor and it is hit on the object and then it is coming back to the sensor. So the total time taken by this sound sensors and divided by 2 will be the actual time taken to travel from sensor to that object. So only we are dividing the speed by time. So only we are dividing this entire calculation by 2, right? So distance is equal to time taken by 2 into the speed of the particular sound ultrasound. So the speed is 0.034 and t is the time taken to travel from sensor to the object, and divided by 2, that is actually, so it is having a two-way travel. So from sensor to the object, so it is the half of the time. So it will take the half of the time. So divided by 2 we are added here, and then this will be the distance in centimeter. So in order to do this, so actually we need to follow this protocol. We need to send 10 microseconds a high pulse through the trigger pin, and then it will be transferred from the transmitter of this ultrasonic sensor. So it will be actually sent by the burst waveform, like you can able to see. It will be divided into 840 kHz sound waveform. It will be transmitted to the atmosphere. So it will be hit by the object. If it is not having any obstacle in front of it, the ultrasounds will continuously travel, and one particular moment it will get diluted. So if any obstacle is available in front of the sensor, surely it will get reflected, and it will be received at the echo pin itself. So this is the time taken by the pulse to leave and return back. So as you can see in the picture, this is the time taken for the ultrasound signal at the echo pin itself. This is the time taken by the ultrasounds. So this is the working principle of ultrasonic sensor. So this is the code for interfacing ultrasonic sensor with the Arduino. So there are two different pins, as I told before, trigger pin and echo pin. So I am declaring this as a constant integer variable, trig pin, that is 9, echo pin pin number 10. So I have connected my VCC at VCC and ground. These are all the supply pins, and we know that Arduino is giving 5 volt and ground pin at its left side. So I have connected voltage and ground to this pin number, to this corresponding power supply pins, and trigger pin of this ultrasonic sensor is connected at the pin number 9, and echo pin is connected to the pin number 10. So physically I have connected trigger at 9 and echo at 10, and also in program itself I have correctly configured the same thing, and I am just declaring the variables like duration, distance as long and integer variables. So these are all called as global declaration. So before opening my setup command, just I am declaring all the recommended functions, recommended variables here, and just I'm setting my trigger pin as output pin and my echo pin as input pin. So these are all the pin mode commands, and as I already told before, serial.begin 9600, this is the serial communication command. The sensor from the distance values from the sensor will be measured by the Arduino board, and the Arduino board wants to show the distance in serial monitor. So as you can see in the Arduino IDE, this is so called serial monitor. It is available in the top right corner. So serial monitor is actually the option where we can able to see the distance like this. So we can able to the sensor is actually now printing the distance. So distance is 240 centimeter. Just I am just interrupting its line of sight with the help of an object. Now it is showing 8 centimeter. Just I am bringing the object very nearer to the sensor. It is showing 3. Just I am going back. Now it is 15, 16. These are all in centimeters, right? So this is the output. So this is so-called serial monitor. So now the data travel, you need to understand the data is actually generated by the ultrasonic sensor. It is given, it is collected by Arduino UNO, and it is somehow it is processed, and it is finding the displacement value, right? This displacement value from the Arduino itself, it has to be sent to the laptop. Laptop means this, or to this Arduino IDE I have to send. Where I can display my results, the only solution is serial monitor. So there is a dedicated class is available under serial class. We are having a command called begin. So call the class and call the command and tell the baud rate is 9600. As you can see, we are having this different numbers of baud rate: 300, 1200, 2400, 4800. So we are having different baud rates. The universal baud rate is 9600. That's all. So by by initiating this serial communication, you can able to get the data from Arduino board, and then you can able to visualize in this Arduino IDE. So this is setup command. So this is purely telling about your hardware details. And then loop command. So now as we discussed earlier, we need to trigger the pulses. I mean via the trigger pin itself, you need to send 2 microseconds of a small trigger pulse. Then you have to wait for 10 microseconds. That is the actual process. So I'm just sending the I'm just sending the for the 2 microseconds I'm sending the low state through this trigger pin, and then I'm waiting for 2 microseconds, and then I'm sending high for 10 microseconds, and I'm making the trigger pin as low. So by the way, with the help of these 5 lines, you can able to understand this pulses we are sending. Okay, right? This trigger pulse initially 0 for 2 microseconds, and 10 microseconds it is high, and it is again 0 for the rest of the time. So this is the actual process what we are doing in this line. Then afterwards I'm using pulse in API command, where I'm just started observing whether the echo pin is receiving high or not, right? So at the moment it will receive the high until it is losing the high state. So it is, this command is measuring the duration. Okay, I told before, if there is an obstacle in front of the sensor, surely it will get reflected. Once it is getting reflected, and it will be surely received by the receiver, and when it is receiving, actually the duration of that echo pin is actually measured with the help of this command. This is the time taken by the ultrasounds to travel from sensors to obstacle and obstacle to sensors, right? Then the duration is distance calculation formula. Duration, that is time into 0.34, that is the velocity of the ultrasound, divided by 2. We are dividing by 2 because it is the time travel from sensor to obstacle, obstacle to sensor, right? So we need to divide by 2, then only we can able to correctly get the time period and as well as the distance. Just I am printing the distance string, right? Within the single double quote I am just printing distance. Then serial.println distance. This is distance variable which is previously used here. This distance is actually measured in terms of centimeter, and delay it for every 0.5 microseconds. This particular device is actually, when this code is actually measuring the distance between the sensor and the obstacles in front of it. So it is getting diluted, so maximum 240 250, this kind of distance you can able to see here. So if I am showing an object in front of this sensor, it is showing 10 centimeter gap, and if I am just going closer to the sensor, it is also precisely measuring the distance as 5 or 6 centimeter. So this is the process of interfacing an ultrasonic sensor with the Arduino IDE. Thank you.